now let's go through the practice. So write the IUPAC name for the following compounds. Remember what step 1 is. Step 1 is to find the parent chain. And remember, the parent chain is just the longest chain. So what I like to do is I like to draw a little line. And on top of that, I'm going to put the parent chain. And below that, I'll just bullet any substituents that I have. Okay, so let's look at our example here. Well, just looking at this, our parent is going to be this. Okay, oh, and if you want, if you're not familiar with this, you can watch this section. But if you want to give yourself some time to practice by yourself and then watch it, you can just pause the video. So this can be the parent chain. Or if you wrote this instead as the parent chain, that's perfectly fine, because it's the same thing, right? This is a methyl group, this is a methyl group. It doesn't matter which way I go about it. Alrighty, so now that we've picked the parent chain, let's go ahead and just circle our substituent. Boom, there's our substituent. Okay, so our parent chain has 4 carbons in it. So we're going to use the root name for 4, so bute. And because it's all single bonds, we're going to finish the parent chain with A-N-E, that suffix that we talked about earlier. All right, now we only have 1 substituent, so let me erase all these bullets because we only have 1. And it is a methyl group, so that is methyl. So meth, because there's only 1 carbon, and then we end it in YL because it's a substituent. Now we have to figure out how to number this though. So what I'm going to do is there's 2 ways to number this. I can number it the blue way, 1, 2, 3, 4, or I can number it this pink way, 1, 2, 3, 4. Now remember, when you're numbering the parent chain, you want to number it so that you give your substituents the lowest possible number. So if I number it the blue way, then I have a substituent on 3, and that's it. If I number it the pink way, then I have a substituent on 2. So what's lower? Well, lower is 2, so we're going to go with the pink. So that's how we're going to number our parent chain. So let's cross out the blue. So that means that our methyl group here is at carbon 2. So 2-methyl. Now notice I used a hyphen here because I'm going from a digit to a letter. Okay? So I use a hyphen. Now that I have my substituents listed when there's only 1, this is my parent name, remember? Now I'm just going to put them together with no spaces. So it's 2-methyl butane, just like that. All right, so let's do the next ones. So looking at the next one, I can see that my parent chain, you could say this is your parent chain or this, it doesn't matter because both of these are methyl groups, so it doesn't matter which one of those you use, and both of these are methyl groups, so it doesn't matter which one of those you use. You'll still get the same answer. But I like to keep my life easy, so I'm going to go with the ones that's just straight across. All right, so again, I like to draw my line, and then I say, okay, we've got 1, 2, 3, 4 carbons, so it's butane. This time, though, I have 2 substituents, 1, 2. Now, they're both methyls, okay? So what I do is, instead of saying, well, first let's figure out the numbering, all right? So 1, 2, 3, 4, I can number it the pink way, in which case I have substituents on 2 and 3, or I can number it the blue way, in which case I have substituents on 2 and 3. And notice it doesn't matter which one I picked because they're both 2 and 3. It's at this stage that you would use the alphabetical order to figure out, do I do pink or do I do blue? But the funny thing here is they're both methyl groups. So they're both the exact same group, so they have the exact same name. So they are exactly the same when it comes to alphabetical order. So it doesn't matter which one you pick, okay? The other thing is when substituents are the same, we group them. Okay, we don't list them out individually. For example, you would not say 2-methyl, 3-methyl butane. Okay, because that's just too much work. What we can do instead, and this is what you're supposed to do, is you group them together and you have a prefix in front designating how many of that group you have. So don't do that. What we're going to do instead is we're going to say, all right, we have a substituent at 2 and at 3, and they're both methyls, and there's 2 of them, so it's dimethyl. A lot of students forget to have that prefix designating how many of that group we have. You don't want to forget that, okay? And so really, when we list this out, it's just 2,3-dimethyl butane. Okay, now notice when I was going from a digit to another digit, I separated them via a comma, okay? However, when I was going from a digit to a letter, I used a hyphen. Alrighty, so for this one, what is the longest carbon chain? Well, it is this one here. Alrighty, and so how many carbons do we have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8. So that'll be octane. And we only have one substituent here. Okay. So, how are we going to number this? So, the pink way, we can do 1, 2, 3, 4, 5, etc., etc., etc. We're just going to go up to the substituent. Or the blue way, 1, 2, 3, 4, 5. So this time we're going to use the pink numbering system because we get the substituent at number 4. If we number it from the bottom with the blue numbering system, we'll have the substituent at 5. So we want the lowest substituent number possible that we can get. So this will be 4-methyl. All right, and so putting this all together, it'll be 4-methyl octane. All right, and so we just got 2 more left, and then we'll stop the video, and then we'll go on to the next one in the next video. All right, so here I've outlined the longest parent chain in yellow. Now, sometimes it is easy to see what the longest parent chain is. That's obviously the longest parent chain. For me, that's obvious. But sometimes you have to go a few different ways. And actually, the next one looks a bit complicated, so we'll probably do that. And so I have a substituent here, and here, and here, and here. Okay, so let's write out what we've got here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So nonane is our parent chain. Now the question is how are we going to number it? Oops. Nonane. How are we going to number it? Oops. So we can do 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we number it the pink way, we have a substituent at 3, 4, 5, and 6. They are different substituents. Some of them are methyls and some of them are ethyls, but that doesn't matter when we're picking the numbering system. We're just trying to figure out which ones will give us the lowest number. All right, so if we number it the blue way, where this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So then we'll have substituent on 4. Now automatically, since 4 is where the first substituent will be, and 4 is greater than 3, automatically right now I know that I'm going to use the pink numbering system. But I'll just keep going. So 4, 5, 6, and 7. Now when you're choosing a numbering system, you go by the first point of difference. So what that means is, notice here, are 3 and 4 the same number? No, 3 and 4 is not the same number. And so that's the first point of difference. And so that point is what we're going to use to see who has the lowest number and go with that. So for example, you could have numbering system 1 versus numbering system 2. And let's say I have 3, 5, 20, 100, 101. I'm just making these up. And then if I numbered it a different way, somehow a different numbering system would have gotten me 3, 4, 10, 30, and 45. Of course, this is not possible. I'm pretty sure this is not possible, but what I'm trying to show you here is the rule that we use called first point of difference means that you start here. So 3 and 3. That's the same number. So that's not a point of difference. So we move on. Okay, what about 5 versus 4? Are they different numbers? Yes, they're different numbers. And because that's the first point of difference, we go with whichever one is lower. So here, 4 is lower than 5. So automatically, based on the first point of difference rule, we would go with the second numbering system. Even though, well, actually, that's pretty much it. So first point of difference, the first point that you have different numbers, you pick the numbering system that has the lower number at that position. Okay, so we're going to go with pink here, not blue. So let's see, we've got 2 methyl groups and 2 ethyl groups. And remember, if they're the same substituent, we group them. So our methyl groups are on 1, 2, 3, and 5. Okay, so we've got 3, 5 dimethyl. Okay, don't forget that prefix that says we have 2 of them. All right, and then we've got 4 and 6, 4, 6 diethyl. Okay, so this is the first question where we have more than one substituent. So what we need to do is we need to list these substituents in alphabetical order. Now here's the interesting thing. When it comes to Latin prefixes, maybe it's Greek prefixes. When it comes to, I'm just going to say Latin prefixes, and these include di, tri, tetra, right? These are just showing the reader how many of a substituent we have. We do not include di, tri, tetra, penta. We do not include those Latin prefixes when we're considering the alphabetical rule. So let's look at our nonane here. So nonane. So we know nonane is the parent chain. It's going to be last. So let's write that. Nonane. We'll write at the end here. Okay. Now who comes first? 3,5-dimethyl or 4,6-diethyl? Well, remember, we have to look at the alphabetical rule, but we are not going to look at the di prefixes, okay, because they're Latin prefixes. We don't look at those for the alphabetical rule. We want to look at the actual root the methyl versus the ethyl, okay? So we're going to look at M versus E. What comes first in the alphabet, M or E? Well, E does. So the 4,6-diethyl is going to be listed first because comes first in the alphabet, because E comes before M in the alphabet. So if we write that out, 4,6-diethyl, then we'll have 3,5-dimethyl. Now notice here's a letter L. The next thing I'm going to write is this number 3. So when I'm going from an L or a letter to the number 3, a number, what do I put between them? Well, because I'm switching mediums, if you will, from letters to digits, I need to put a hyphen between those. So we will put a hyphen, and 3, 5, oh no, I'm going to run out of room. Dimethyl. Squeeze that in there. There we go. So it's 4,6-diethyl, 3,5-dimethyl nonane, and that's all one word. Okay, so look at this beast down here. So, just looking at it, we might have to figure out where the longest parent chain is. And I'm not sure what that, well, all right, so let's say we do this. Maybe this is the longest parent chain. Let's count how many that would be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That'll give us 10. All right, let's see if there's any other ways we could do it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, no, not that one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That also gives us 10. Yeah, I think those are really the only long ways I can see. So, interesting. So, we've got yellow, orange, and green highlighter. Of course, you can't see the yellow anymore, but the yellow, let's color code these. So, the yellow that we're used to doing, so the yellow highlighter had 10 carbons in it. The orange highlighter had 9, and the green also had 10. So automatically, 10 is the largest carbon chain, right? The longest chain. So we can get rid of the orange. We don't care about the orange because we have 10, and 10 is longer. The question, though, is we've got the yellow, which is 10, and the green, which is 10. So which one is the right parent chain? Because they're both different, all right? Well, the answer is you want to choose the longest parent chain. Okay, we get it, 10. But if there's an option where there's more than one way to pick the longest parent chain, in other words, for this example, I have 2 different ways and they're both 10. So which one do I pick? Well, you want to pick the one that has the most substituents on it, okay? So let's go ahead and circle in yellow all the substituents for the yellow parent chain. So if I use the yellow parent chain, in fact, let's make this easier. Let's do this. So here's my yellow parent chain. Where are my substituents and how many do I have? So 1, 2, 3, 4. Those are the 4 branches coming off of the parent chain. So 4 substituents. And now let's erase that and try the green way. So the green way, we did it this way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. All right, so where are the substituents on this green parent chain? 1, 2, 3, 4, 5. All right, so if we use the green parent chain, we actually have 5 substituents. And so because the green parent chain actually has a higher number of substituents, we're going to go with the green parent chain. What this does is it makes the substituents easier to work with. If you choose a parent chain that gives you more substituents, it's very likely that that simplifies the substituents into more simple groups versus if you would have chosen the parent chain with the less substituents. For example, on this green one, I've got a methyl, an ethyl, a propyl, and a methyl as my substituents. However, if I had done the yellow parent chain, I would have had a methyl, a propyl, an ethyl, and an isopropyl. So by choosing the parent chain that has more substituents, it has a way of making the substituents more simple and therefore making naming the compound more simple. Okay, so when you have two different ways, two different chains that have the same length, that could be the parent chain, you want to choose the one that has the most substituents. Alrighty, so we're going to go with the green way here. Okay, so we said we had 10. 10 means I'm going to use the parent chain name decane. Okie dokie, so let's go ahead and highlight all of our substituents. So there's 1, there's 2, 3, 4, 5. All right, so now that I have 5, let's figure out which way we need to number this. So again, I'll choose pink versus blue. So I could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would give me substituents at 2, 3, 4, 6, and 7. Or I could do it the blue way, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which would give me substituents at 4. Well, I mean, automatically you can see based on the first point of difference, the pink is going to be the better way because blue is 4 versus pink, which has the substituent listed at 2. So we're going to go with the pink numbering system. All right, now remember we have to group like substituents. So let's see, I've got 2 methyls, so let's put those together. And those are at carbon 2 and 7. So 2, 7, dimethyl. And I have 2 ethyl groups at 3 and 4. So 3, 4, diethyl. And I have 1 propyl group at 6. So 6 propyl. Alrighty. So now when we name this, we need to list the substituents in alphabetical order. And remember, we're ignoring the Latin prefixes di, tri, tetra, right? So we're going to be comparing the M, the E, and the P. So what comes first in the alphabet? Well, that would be E. Then comes M, N, O, P. So then comes M, then comes P. So it'll be 3, 4, diethyl, 2, 7, dimethyl, and then 6 propyl, oh goodness. Six propyl, and then decane. Let me just shrink all of this because it's not going to fit. All right, so we've got there we go. 3,4-diethyl-2,7-dimethyl-6-propyldecane. And that is how you would name this molecule. And so that was a lot. And we'll go over naming complex substituents in the next video.